In this video, we carry on with our discussion of joins, and this time we're going to look at semi-joins and outer joins. So again, the overall context is relational algebra, things we can do with relations or tables in databases, sort of things that come up in querying. So we are sort of making another table. So and we have various operations we can do. Select a table as sort of rows and columns, and particularly a relation means we don't care about that the rows must be distinct, and we don't care about their order. And same thing for columns, we don't care about their order. That sort of tends what to make a generic table into specifically a relation. Anyway, we have operations like select, which is to pick out certain rows, project, which is to pick out certain columns, and Cartesian product, where you sort of smash two rows from different tables together, sort of concatenate rows and make all possible combinations, which on its own is not a very useful thing. But if we add in the operations of selection and projection to Cartesian product, we end up with a join, which is quite useful. And the selection is based on some condition, on some predicate, and that's some kind of comparison, greater than, less than, equal to, and we're going to be working with equal to, so we're going to be working with Equi-joins, and we just want to move away from the idea that having two things from each table and match. So the first thing we're going to do is a semi-join where there's a match, but we don't ask for anything from the second table. So we can have like customers who have ordered something. So order will have a customer table, and we can ask for customers. So we can look for the customers who made an order, but we're not necessarily interested in the order. We just want to know who's ordered something. And that would make it a semi-join. So we're going to have, in our query, you're going to have the relationship to order, but then in the fields that we want, none of them are going to be from order. Okay. So we're going to sort of do a join, but only ask for half of it. And one that might be what you're interested in, just that might be the question you've asked. Tell me the customer who have orders. I don't need to know anything about the orders, but just tell me the customers who have orders. Or I could say in some distributed system and I want to send some information around and not have it be too large, then I might want to sort of break the information down and sort of manipulate it further, like on the other end. Okay, so here I have customers relating to order, and I want the customer ID, which is in the order table, which is the foreign key, to match customer ID, which is the primary key of customer. So fairly like a regular old join, except in the fields I'm asking to see, I'm not asking to see anything from order. So that makes it this sort of semi-join. I'm sort of looking at the relationship, but only from one side. Okay, so I do this. I had this little database in Access, and I have I looked at just the customers, and I have Jane Doe twice because she had two orders. Now, once we bring in sort of aggregation, then I can sort of count the orders and say, oh, Jane Doe had two orders or something like that. I can sort of count up order IDs or something. But I'm not doing that here. I'm just saying ordered or not ordered. And so if I'm doing that, then I might not want Jane Doe twice. And I can do that easily enough by just adding the word distinct. So here was the join with Jane Doe occurring twice. Select customer.star. I wanted all the customer information, but I don't have any order information, making it the semi-join. But I do have in my from, I do have customer inner join order on the customer ID matching the order ID. So there has to be a relationship to an order, but I don't necessarily want any order information. This is the semi join. Here I've added the word distinct. And so if you have multiple orders, I will only get you once in my results now if I add in the keyword distinct. And there I got rid of the duplication of Jane Doe, and she's only appearing once now. Okay, now we're going to look at sort of an opposite situation where I want information from customer and order, but I might want to have include in my list customers who have not made an order. So if I'm interested in a relationship where there's some kind of matching, but I also want records that might not match, I'm doing an outer join. And then specifically, they break it down. And this depends on just the order of the tables as you're writing them down in your SQL statement. But they will usually divide outer joins into right joins and left joins. And they're going to keep unmatched records. Okay. So now I'm back in my former access example. And when you sort of make a join query, sort of either be it the wizard or query by design, um, they tend to automatically assume that it is the inner join, that you don't want unmatched records, but they give you the option to do the outer join and to get the unmatched records. You just have to work a little harder. So here is a customer order. So the order had a foreign key, which was the customer ID. It matched the primary key of the customer table. We just sort of set it up quickly, and that was the standard inner join. So select customer name, customer last name, customer first name, order ID from customer inner join order on customer ID equaling order ID. Here's sort of garden variety natural join. So this is all still inner. But if you want customers, even if they haven't made an order, then you want an outer join. And you can, that line sort of representing that line between the two tables, those two rectangles representing the tables, you can right click and sort of edit it. And so we're going to specify that we don't want the default inner join, but we want some kind of outer join. And then it chooses, just based on the order in which you place things, a left table and a right table. Sort of, this is just like the order in which they appear in the SQL, or when you were designing it, the order in which they appear. And then you have to decide which unmatched thing you want. So it's saying, do you want all customers and then order? I mean, I don't think I have any orders that don't match a customer, but it would be possible that each table had unmatched things. But in this case, we decide that every order has a customer. We probably did that for referential integrity, but there are customers who didn't click, didn't actually order. They started to order things and then they stopped, but they're in our database. So if we want customers, even if they didn't order things, then we specify that in this syntax that we want records from customer, but only order if they match a customer. And it gives you the other option as well. So you have to pick, and basically you're picking a left join or a right join when you're doing this. So now what used to be just a line has an arrow. This is their notation in Access to emphasize that this is now an outer join. It's going to include unmatched records. And then it's an arrow, so it has a direction. So that's telling us sort of left or right. Okay, and so this is select customer, customer last name, customer, customer first name, order, order ID from customer, left join, order on customer ID equals order ID. So this, again, we are getting some unmatched records here. And so we have customers who don't have any orders. So there are no order IDs for Betty Rubble or June Allison or John Brown. And that is an outer join. Now I hopped over to the W3 schools, and they're working with a Northwind database, which is a fairly standard database for learning on. And here's their example of this was a left join. So there was customer table and orders from customers left join. And this is sort of what we were just looking at in my little database with Betty Rubble in it. And the customer ID is the order customer ID. And then they've added an order by, so they're putting the customer names in sort of an alphabetical order. And we see here that the first customer has no order ID, never ordered, never made an order. And that was a left join because the customers were first. Their example of a right join, they have again this Northwind database. When you make an order, an employee sort of handles that order. So there's an employee ID in an order. And so in like a customer may have multiple orders, but an order had one customer. Similarly, an employee may handle many orders, but an order is handled by one employee. So the order table had a foreign key for the customer and had a foreign key for the employee. But here this time we put orders first and employees second, and we wanted to even include employees and haven't taken any orders, and so this was a right join. So the second table we had orders and then employees, and this time it's the second table where there are things where we want them even if there's no match. So you just have to decide which table is first, which table is second, and then which table you want to include unmatched things in, and that will determine for you the right or the left of it. And those are my references. That's it for this one. Thanks for your attention.